Good afternoon, everyone. Thank you very much for being with us today. I would love to thank the people in the room, as well as all of you who join us via Zoom. In particular, I would love to say thank you to the International Association for Study of Pain, to Greg Carbonetti, and all of you who join our lecture across countries. Also, I would love to tell you about our PBO Center. Why PBO? Placebo Beyond Opinions. The reason why we name the center as PBO is because we aim to advance science beyond opinions, beyond misunderstanding. And the goal, this is a new established center. The goal is to create connection across labs here at UMB, but also with other collaborators. And today I wish just to spend a few minutes to show to you where we are, our website, and actually you can learn more about our mission, our goals, as well as the possibility to join us without any cost. So once you join us, you will learn more about the research we do, as well as any collaboration and papers that we will be publishing as part of this center. The next step will be to introduce my Associate Director, Professor Jason Noel, and he will be introducing our speaker today. Thank you for joining us again. Thanks.
Good afternoon, everyone, and hello, everyone internationally. Really excited to hear our talk today. Dr. Fadel Zeidan is a neuroscientist and an associate professor in the Department of Anesthesiology and director of the Pain Health and Mindfulness Laboratory at the University of California, San Diego. He's also the inaugural endowed professor of empathy and compassion, I'd say. Very interesting title. But this all ties into some of the great work he's done, looking at mindfulness and how that can support being healthy and specifically have analgesic effects, which we'll hear about today. Dr. Zeidan's current research is focused on determining the psychological, physiological, and neural mechanisms that mediate the relationship between these self-regulatory practices, such as mindfulness, and how that relates to health. And again, this really contributes to his work around looking at mindfulness meditation, psychedelics, and cannabis on pain and analgesia. He'll share a lot of his data with us today, but he's demonstrated that mindfulness meditation actually is mechanistically distinct and actually may be a more effective way of inducing analgesia compared to placebo, distraction, and relaxation. So without any further ado, I'd like to introduce the presentation entitled Neural and Physiological Mechanisms Supporting Mindfulness-Based Analgesia as Compared to Placebo. Thank you. Right on PowerPoint?
Yep, good. Just click the icon on the bottom. Oh, if you look at the screen there, it makes it a little bit easier. Did you have those? Yeah.
Oh, there it is.
Yeah, it's just because it's set as two screens.
Yes, sir. Great. Thank you. Thank you so much, Dr. Noel. And really, I'm just so grateful to be here. Flattered, honored. Dr. Luana Kaloka, I've known you for almost 20 years maybe, and just really flattered and honored to be invited. Everyone's been just so hospitable and kind, and it's really this contagious energy within the laboratory and the center about all the wonderful big questions you guys are answering. So yeah, I'll be talking about my research, and feel free to ask questions, and I'll repeat the questions for the audience on Zoom.
As you all know, we're in the middle of a chronic pain epidemic. And we're also, in light of that, in the midst of an opiate epidemic, where we don't really have a way to treat chronic pain effectively. Pain is a multimodal, multifaceted problem that likely requires a similarly multimodal and multifaceted solution. And we are in such a dilemma that our own Centers for Disease Control say that the #1 avenue for pain relief need to be non-pharmacologic approaches. Opiates, intrathecal injections, surgeries aren't necessarily or really predictive of relief in the long term when we look at the full model, but rather non-pharmacologic approaches like cognitive behavioral therapies and physical exercise can be quite efficacious. To that extent, we've seen growing literature that 8 weeks of manualized meditation training can produce pretty robust improvements on the spectrum of chronic pain conditions. In particular, the 8-week mindfulness-based stress reduction program, which was developed by John Kabat-Zinn, is the most studied and reliable, I guess, in the context of relief manualized intervention, which requires 8 weeks, an hour, 3 hours a week in formalized training, 45 minutes a day of homework, a silent retreat, which is 3 days and about $600, which doesn't necessarily sit well with our community dwellers that, have jobs and, families and not that much money. We also live in what I call a drive-through society, where we as Westerners like things that are quick and easy. We have a tendency to eat our food with our flip phones in our car. And, we have this thing called 8-minute abs. Hold on, I'm just going to move this icon thing. Got it. 8-minute abs and buns of steel in 8 minutes. And this is super attractive. And we even have this diet called the military diet, where they promise that you'll lose 10 pounds in 3 days without dying. So all of these things are quite attractive, and they're quite efficacious almost immediately. And maybe, when I started this research over 20-something years ago, well, maybe you don't need to be a monk for you to reap the benefits. Maybe you don't need to practice every day for 8 weeks, et cetera, for it to be beneficial. So we've developed, in North Carolina, we developed a brief mindfulness-based intervention, 3-4 sessions only, 20 minutes a session. And here we teach people how to practice mindfulness meditation and how to do it independently. So folks are taught to sit with a straight posture with their eyes closed and to focus repeatedly on the changing sensations of the breath, tingling cool air as you breathe in, the warm flowing air as you breathe out, mentally noting the rise and fall of the chest, belly, and so on. And not if, but when your mind gets distracted, they're taught to acknowledge distracting, discursive sensory events, thoughts, feelings, without judging themselves, without judging the experience. So it's a very effortful, disciplined practice that combines enhancements in cognitive control and flexibility with emotion regulation. So there is no, belief in something, right? It's a mental practice that's analogous to physical training, right? So, and we found that this intervention can be quite efficacious on several outcomes. And so mindfulness has really, taken hold. It's been quite a journey to see how much this has changed. When I first started studying mindfulness and was explicitly told by my mentors to stay away from studying meditation if I wanted a serious career. Not sure if I've attained a serious career yet, but regardless. And, we have these, images in our mind. We have LeBron meditating on courtside. Time magazine continuously puts meditating on people on the cover, and, Oprah's meditating with her Oprah blanket, and we have these images of Vietnamese protesters and the zenith of all popular culture. Anderson Cooper is now meditating on TV. So a lot of these things could elucidate non-specific effects, conditioning effects, expectations, beliefs that can actually drive analgesia as we know it through meditation. Further, the context of beliefs and the majority of meditation, standardized interventions, there's the words called the power of meditation, which is inherently analgesic. Slow breathing is also a quote unquote side effect, which can contaminate the true signal of whether or not mindfulness is efficacious. And true with all interventions, facilitator retention, social support, and conditioning are also potential drivers of the effect. So in an attempt to torpedo my career, we developed a sham mindfulness meditation intervention where, we really wanted something that was operationally analogous to mindfulness meditation because we study the brain. And if I just put placebo cream on your arm and compare that to meditation, your brain's going to look different. So how can we disentangle and tease apart what we consider the active mechanism of mindfulness from a placebo-esque meditation? So we created this thing called sham mindfulness, and it really is a meditation technique. It's certainly not inert, it's just not mindfulness. And here we lead people to think they're practicing mindfulness, eyes closed, straight posture. And instead of focusing on the changing sensations of the breath non-reactively, they're just taught to take deep breaths every couple of minutes. We even matched the amount of time that we gave them instructions in the sham group to the genuine group. So this is a highly efficacious intervention. It works really well, but it just matches everything to the genuine intervention, except, again, this idea that being non-judgmental and present-centered is what we thought or think is the active mechanism. So I'm going to show you results from a trial that where we basically took the majority of our meditation interventions studies and we combined them. So we have a pretty large sample size here. And I'll get into the details of what we do in the lab, but we administered highly noxious thermal stimulation to the back of the calf. This will be 10, 12-second plateaus of 49 degrees Celsius, which is very noxious. And we attain our variability not from the stimulus, but from the ratings. So some folks are going to be insensitive, less insensitive to 49 than others. And on the y-axis, we have the change in visual analog score pain ratings. On the x-axis is a book listening control intervention. They listen to a boring book on tape. Our 4-session sham mindfulness intervention, and our 4-session mindfulness intervention. And you can see that from the beginning of the scan to the end of the scan, that there's about a 20%, there's about a 20% increase in pain for the controls. Sham is dramatically more effective than controls, and the mindfulness intervention, meditation is more effective than sham mindfulness and the controls. So this works in preparation right now. And across 2 different studies using perfusion arterial spin labeling fMRI, which provides us a direct quantifiable measurement of cerebral blood flow. We have found across 2 studies, we reproduced these effects, that 3 areas in the brain are particularly responsive or predictive of analgesia during meditation. This is not the perigenual ACC, unfortunately. This is the subgenual ACC, so I apologize. There's the genual, the knee, if you will. And so higher activity here, and in particular, right anterior insula, which is ipsilateral to the stimulation site. So these 2 areas, higher activity here during meditation, lower pain. And then the bilateral orbitofrontal cortex, which is a very evolved brain region associated with changing the contextual evaluation of a sensory environment. And then the right anterior insula, as some of you may know, is involved in awareness of input bodily sensations, interoceptive processes. So interestingly, these areas are also all super high in opiate concentrations. So, makes us think, oh, maybe this is endogenously driven by opiates. Conversely, we found that the meditation, which is unique to other pain modulations, reliably deactivates the periapical gray matter, which is one of the central nodes of descending inhibition of endogenous opiates. So this is what we have for the perfusion data. And then we recently published a study that, and here's you can't really see it, but it's a beautiful work by Greg Dunn, who donated his work for our cover on pain. We found that using BOLD this time, blood oxygen level dependent signaling, that greater deactivation of the ventral medial prefrontal cortex predicted analgesia. And the VMPFC is involved in a lot of really cool things: self-reflection, subjective value, affective meaning, what the stimulus means to you. So very higher order. And so greater deactivation in that area predicted greater analgesia. And of course, we ran some connectivity, and we love the thalamus. We always see the thalamus deactivate during meditation. And we found that the thalamus, the contralateral thalamus, decoupled from the precuneus. And the greater the decoupling with the precuneus, the greater the analgesia. And these areas are cool too, especially together, because the precuneus and the thalamus are involved in self-consciousness. In fact, they're the first two nodes to go offline when we lose consciousness, and they're the first two nodes to come back online when we recover from consciousness. So together, the precuneus and the ventral medial prefrontal cortex are deactivating, and that's driving meditation-based pain relief, which are the two central nodes of the so-called default mode network, which is involved in self-referential processing, ruminations, things of this nature. And so together, these findings are remarkably consistent with the main tenets of contemplative practices called the anatta, which in Buddhist texts is known as not self, i.e., your experiences are not who you are. That if you can reduce egocentric appraisals of all information that's arising in your mind, whether it's noxious or not, innocuous, those are not who you are. That our emotional attachments of those experiences can actually lead to suffering. And we know this now in the context of chronic pain, that it's not really the intensity or the severity of the experience that's exacerbating chronic pain, but rather the affective dimensions, the interference with our daily lives that's really driving the dysphoric and lack of well-being effects from chronic pain. So we, were really pleasantly surprised that our results were consistent with what we've seen, or what contemplatives have been delineating for 4,500 years, that meditation works by diminishing the value of self-reference. And we proposed in the paper that meditation may work by elucidating a decoupling between arising nociceptive inputs and self-referential processes. So this decoupling between what we're experiencing and how we interact with that. So what happened with the shams? Well, we haven't found neural correlates of sham meditation-induced analgesia. I mean, you saw that the effects were pretty large, but nothing correlated with it in the brain, the pain relief. But we did find in this large sample and in our 2015 paper that sham meditation-based analgesia is associated with lower respiration rate. Now, the mindfulness group and the sham mindfulness, they lower breathing rate exactly the same way, 21% reduction. But we've never seen breathing predict analgesia in the genuine group, only in the sham group. And I love this because it provides a really clear separation between potential mechanisms, i.e., the mindfulness group is engaging a potentially novel pain modulatory mechanism with higher order attenuation of the default mode network. We've never seen the default mode network serve as an analgesic mechanism before in any type of approach, any type of therapy. So that's more of a top-down modulation, versus sham mindfulness meditation is lowering pain by potentially attenuating, slowing down the breath, which to me is more of a bottom-up response, right? So we have this cool little difference between the two techniques mechanistically and behaviorally, and the only difference between the two is that one group is focusing on the breath non-reactively. So that was pretty cool. So that's, kind of like a briefer of, where we are when we put all of our studies together, that we're starting to see this kind of mechanistic separation between a placebo-esque meditation and a genuine meditation. But we wanted to kind of step up our game a little bit, and we started to incorporate more machine-learned multivariate pattern analytical models to identify how meditation interacts with the subjective experience of pain. And is that synonymous, and does that parallel placebo responses? So our colleague Tor Wager has developed what I think reviewer 2 made him call these MBPAs as signatures. I don't think he originally wanted to call it a signature, but If New England Journal of Medicine tells you to jump, you just say, I'll call it a signature, whatever you want me to call it. So the first one was published in New England Journal of Medicine, 2013. And this is where he used beta weights in a subset of brain regions to predict subsequent pain responses at a 99% level, like super high accuracy of predicting pain responses. And the neurological pain signature, as is coined, is nociceptive specific, especially in relation to noxious heat. So when NPS responds to a noxious stimulus, it has 99% accuracy that it's going to be predictive of pain that is nociceptive specific. And you may say, well, what kind of pain isn't nociceptive specific? There's tons of pain that's not nociceptive specific. There's affective dimensions, there's placebo-related dimensions, there's reward. Pain is complicated. It's not just the stimulus. So to that extent, Eon Wu had also developed the stimulus intensity independent pain signature, which also could be the most verbose one, but it is also a machine learned predictor of what he calls cortical contributions to pain, those that are driven by beliefs, conditioning, and expectations, which is what? Placebo. Yes, I knew I could ask that to you guys. So this is really the placebo signature, pain that corresponds to something that goes above and beyond nociceptive specificity. And that's how it was designed too. It responds above and beyond those that are responsive to the nociceptive signal. And then Marta Checo just published a beautiful paper in Nature Neuroscience. And she developed a signature that's responsive to negative affective pain responses that go above and beyond the NPS. So these are pain responses with like a 98% accuracy of prediction that are reflective of negative affective responses. So we basically piggybacked off of these and we combined all of our imaging studies. It's currently under review. And in study one, we had an N of 40 that was randomized to a mindfulness or a book listening control group. This is a group that listened to The Natural History of Selborne, England, Gilbert White, 1907, which many of our participants also characterize as a pain manipulation. And then we scanned their brains after randomization during noxious heat. And then in study two, we had an N of 55. We had 4-session mindfulness, natural history of Selborne, or placebo cream. And this was a placebo cream conditioning intervention that was partially and if not fully developed by Luana Coloca, where we, and I don't know if I'm going to present the data. Oh, I'll talk about it really quick. It's so cool. So we basically administer 49 degrees to the leg, and then we apply a cream that we call lidocaine, and we tell our volunteers this form of lidocaine is really cool because its effects get stronger with multiple applications. So we stimulate at 49, apply and remove the cream after 10 minutes, and then we covertly lower the temperature to 48. In session 2 and 3, we 49, apply and remove the cream, and we covertly lower the temperature to 47. And on the 4th conditioning session, 49 cream, and then covertly lower it to 46.5. Why would I do that? Why am I lowering the temperature after the cream? I'm hearing a lot of mumbling, but I need some confidence. This is a safe space, guys. No, the camera's not on you. You can be wrong. What? Yeah, conditioning is a good word, but what am I actually doing? Can you use the sentence? Thank you. Yes. I'm letting them think that the cream's working, that it's lowering the temperature, and after more applications, it's working. So then they come back into the scanner, and we, instead of lowering the temperature after we apply and remove the cream, we keep it at 49. And that's, voila, how you can measure placebo one way. And in essence, it's placebo conditioning, which is one of the main, at this stage of the game when we were doing this work, was one of the main mechanisms people thought meditation worked. It's like, oh, the more I meditate, the better I must feel, right? That's a conditioning effect. So the same is true with the cream. So we really wanted to parallel that mechanism. Okay, so what else is cool is that in study one, we used bold fMRI. And in study 2, we used perfusion fMRI. And this is the first study ever to apply these signatures to perfusion data. So that's that. So that's the basic design. And let's get to the behavioral data. We see that I'm sorry about how small these are. On the y-axis is pain intensity and pain unpleasantness on this. On the x, we have control, placebo, mindfulness, control, placebo, mindfulness. And you can see that the controls from the beginning to the end of the scan, we continuously see this 20% increase in pain. Because guess what? Getting pain over and over really sucks. And then when you're inside of a big magnetic bore, it sucks even more. Okay, so that's the medical term. And then in the placebo group, we see a significant reduction in pain intensity and pain unpleasantness. But here we're happy or not happy. I mean, it's cool to show that the mindfulness meditation technique is more effective than placebo and the controls. And then you can see here that the unpleasantness dimension is being impacted more than the intensity, which is also consistent with what we've seen with other studies, and the fact that meditation is likely working more on affective dimensions of pain. Now, if we only had an MBPA signature that can help us answer that, I thought I'd never ask myself. So here we have on the y-axis is the nociceptive pain signature. This is the one that's explicitly, accurate at looking at thermal-induced pain. And then x-axis are the same groups. You can see here that the higher pain in the controls corresponded to higher NPS, MBPA. And we didn't see an effect with placebo, but we saw, I mean, you look at this, right? You can see here that mindfulness meditation also reduced not only pain intensity, pain unpleasantness, but also the NPS. And this is quite a dramatic drop, if I may say so. What about negative affective signatures? Y-axis here, and then x-axis are groups. Again, you see that in the controls, there's higher negative affective MBPA responses in the controls, and the exact opposite is happening in the mindfulness group. That mindfulness, just to put it together, is lowering nociceptive specific and negative affective pain signatures. Okay? Is it also modulating the placebo? Is it also a placebo effect? Is it also engaging placebo-esque mechanisms? And the answer is no. No change in the placebo MBPA signature with the controls or the mindfulness group. But you can see here, and this is a beautiful manipulation check, if I may say so, the placebo cream did lower not only pain, but the placebo-specific MBPA, which allows us to kind of mechanistically dissect what's happening with a meditative state versus a placebo condition. So I'm going to get into endogenous opiates, but I want to also see if there's any questions really quick that you want me to clarify on the brain.
Troy Levine says we're subject asymptomatic for subjects currently living with chronic pain.
The question is, are these healthy or patient populations? And these are very healthy people. The patient work will be hopefully coming out soon. It's a great question. We come from the world where we like to do work first in the healthies and see if we can move the needle there, and then we move to patients. Thank you. It's a great question. Is that it? Oh, yes.
I just have a quick question about scanning the brain when people are meditating. We've had participants who are deep breathing themselves because they feel nervous, and then we haven't gotten a very clear scan. So how do you do both of those at the same time?
Great question. Question is operationally and from a data integrity standpoint, if people are breathing slower or meditating in the scanner, how does that impact the data? Because there's potential emotion, and there's other things too. When you output greater CO2 from deep breaths, it actually makes gray matter and white matter activation go down, but the gray matter activity goes down slower than the white matter activity. And the resulting image is a lot of white matter, and it looks like noise. So there's multiple things we do. First, we tell them not to move. Okay, that doesn't work. Okay, that doesn't work per se. We also have these custom-made pads that help as well. No one is explicitly told to breathe slower. They just do to catch up with the breath. But The reason we used perfusion fMRI in our first two studies is because perfusion fMRI, or drill spin labeling fMRI, is less susceptible to respiration-related compounds, A, and B, we actually have a direct measurement of CBF, so we can actually use CompCore and ICA methods to clean up the data from respiration-related compounds. So the long story short is it's hard, and it's good to recognize that it's a problem with any kind of breathing intervention in the scanner, but there are ways to correct for it if you are aware of the issue. And also, you can't just regress out the respiration rate because that's where the signal is. So, yeah. Okay, one more, okay.
So related to that, so since the gray matter is like slower, so does that limit the time that they spend in the scanner, or how much time the effect, how long they can be in there?
The question is, how long can we keep them in the scanner, and does the breathing effect drive that? No, so as long as we're controlling for it and cleaning up the data, we're okay. We used to keep people in there for 2 hours. Now we do it for less because they're patient. We're doing more patient work now. They can't. It's not.
We have one more question.
Okay.
Are these benefits more to chronic pain or acute pain, and are there any differences in effectiveness or mechanisms of action?
So the question is, I think it's the same question as the first one. Is there a difference in healthy and chronic pain?
Chronic and acute.
Chronic and acute pain.
And are there any differences in effectiveness or mechanisms of action?
So I'll show some data on that. I do have a new clinical trial that just finished. Well, it's not new, it's old. It's very old. It just finished. We just got unblinded. I haven't told anybody the results, but meditation was stronger than sham meditation and controls in response to evoked low back pain. So we had radiculopathy patients, and we evoked the radiculopathy in the scanner. And then we asked the question, can meditation be used immediately to assuage that pain? And the answer is yes. So, and I'll show you some data now to answer that second part of the question. But meditation works on the acute and the chronic pain. And likely they're related.
Also, one more question. Looking for pain biomarkers linked to brain images, great about IL-6.
Interleukin-6?
Yes.
Have we looked at interleukin-6? We are looking at it right now, but I don't have any data to present. And when I say we're looking at it right now, we're running a clinical trial where we are looking at blood biomarkers and the interaction between gut and brain as well. Okay, I'll continue. Thanks for those questions, guys. Okay, so now let's go to another mechanistic endeavor of looking at the role of endogenous opiates and meditation-induced analgesia. Endogenous opiatergic system is considered the central opiatergic system. It's the most studied, and we'll get into why, but there's not tons of systems. There's the serotonergic, there's the endocannabinoid, there's the, dopamine system. There's tons, right? The second most populous system is the endogenous opiatergic. The number one most populous is the endocannabinoid system, CB1, CB2 reception. And what we can do, and this is the paper I was referring to earlier about the naloxone usages. So with the conversation I had with your lab, Siri Leknes published a really nice paper looking at how we can reliably block the 3 different opiate receptors. And you can do that with naloxone, super high dose naloxone. John Levine discovered in '78 that you can block endogenous opiates by injecting rats with naloxone, and this was placebo. So naloxone, if you're not on opiates, naloxone is a wonderful tool to understand if endogenous opiates work. I'm glad to hear that you guys are doing such great work in that space. So Katja White published a nice review paper on this, that endogenous opiates are drivers of placebo, analgesia distraction, acupuncture, transcranial magnetic stimulation. Jeff Brocard and Mark George published a beautiful paper where they actually brought TMS into the scanner. You should see their setup, it's really scary. But, TMS works, but when you inject people with naloxone and block endogenous opiates from working, it can stop working. And this is true also for prior hypnosis. They all generally work through endogenous opiatergic systems. What we also didn't know at this time was if there were any treatments that can be used to immediately assuage one's own chronic pain. The majority of our patients, they bend over to tie their shoes or whatever, roll over in bed, and they flare, they injure themselves, and that's their day, week, month. I am taking this pain research very seriously and have been suffering with sciatica for the last month. I have not felt my right leg in a month, and this isn't about me. We're going to keep going. So there are no treatments that are known to immediately assuage evoked pain. And we wanted to know, can mindfulness meditation as compared to sham mindfulness reduce evoked pain? And if so, are they using endogenous opiates to do so? We published a few papers on meditation and endogenous opiatergic blockade in healthies, and this is the first time we've done it with patients. So this is a double-blind crossover randomized trial, 59 low back pain patients with radiculopathy, and we evoke pain with the straight leg raise test, which is normally used as a diagnostic metric for radiculopathy. So if I lift your leg up and between 15 and 60 degrees, you say, ouch, that hurts, then you're called SLR positive, i.e. you have radiculopathy. So instead of using it as a diagnostic tool, we used it as a pain evocator, and we're targeting a 2-point increase in pain. And then we looked at pain before and after the straight leg raise test using the visual analog scale, where 0 is no pain and 10 is the worst pain imaginable. And so that's the basic design, and here's the more flushed out design. Session 1, we performed straight leg raise test, collected pain, straight leg raise test, pain. We have a 10-minute rest to control for the time here that we injected people with the bolus. Then they were randomized to a 4-session mindfulness or sham mindfulness meditation intervention. Session 6, they got naloxone, and we used the highest dose in the literature, 0.15 milligrams kilogram bolus, so it's a massive dose. And then naloxone metabolizes immediately, like within a minute, if less. And so we added a maintenance infusion throughout the rest of the study to ensure that endogenous opiates were blocked. And then if they got naloxone in session 6, they got saline in session 7, and vice versa. This was randomized and counterbalanced. All right, and this work was published in Neuropsychopharmacology in December. Laura Khatib took that paper. I think, is this the one I want to show? I don't want to show this. Oh yeah, I do. Okay. So here is SLR1 and SLR2 at baseline. The y-axis are numerical pain ratings. The x-axis are the mindfulness versus sham. So you can see here's baseline, and then you can see that both groups lowered pain during saline. So this is saline session, and then this is the naloxone session. So both techniques lowered pain immediately. Both techniques lowered pain independent of endogenous opioids. However, mindfulness meditation was more effective at reducing pain during meditation. And we also found that mindfulness was more effective at lowering pain when they weren't meditating after the intervention. So that gets to that question that we heard earlier. It impacted the state and stabilized chronic pain. And we also saw the same effect with the brief pain inventory. So that's a new one. And then there's a caveat to this. And I think I'm going to finish early, which is good, but I might have another study for you. So, so here we wanted to see. This is work by Michaela. I don't know if I don't know if I put her in here. Michaela Reyes. She was an undergrad, super interested in sex differences. I said, go for it. And what we see is that females report higher chronic pain than males. They're prescribed a higher level of opiates. Opiates seem to work that well for females. We wanted to know why, right? And some studies show no sex differences in analgesic efficacy in humans. But in rodent models, that's the exact opposite. It's quite consistent. One of my favorite studies is from Anne Murphy, and she published a study in JNeuro where they looked at rodents, and this is withdrawal latency. So the longer you wait to remove the paw from the heat plate, the less it hurts, versus if it hurt more, it's more reflexive. Right? So in the dark blue, they injected morphine in male rodents with saline, and you see a really long latency. And then in the female rodents, which is right here, you can see a clear difference in morphine analgesia, way more effective in the male rodents than the female. However, when you inject naloxone and morphine in the males, the effect goes away. The analgesia is like reversed, almost like it's dramatically reversed. But if you see here, when you inject morphine and naloxone in the female rodents, it looks like the males when they're getting morphine by itself. So in rodent models, we see over and over that females are not using the endogenous system, but males are. So Michaela and John put this study together, John Dean, where we administered noxious heat. This is an N of 98, 39 healthies, 59 patients with low back pain. We administered 48 degrees, something on the back of the calf. This is our machine, you like it? And then they get 2 heats, and then they get randomized into mindfulness or sham mindfulness intervention. And then I went through this phase where I stopped calling it sham because it wasn't a sham. It was like super effective, but I'm back. And then in this intervention, they get saline or naloxone or vice versa. Are we good? Clear? Good? Okay. I have a tendency to talk fast when I drink so much coffee. Okay, so then, oh yeah, I love this. This is John. This is John's Oscar clip. You like that? That's his R3 reflex. Let's see if it happens. Oh, let's go back. I don't know if it's gonna work. Did it work? There it is. Like that, it wasn't on. Anyways, so that's the noxious heat paradigm, and then if it's hot enough, it elicits this, what's called the R3 reflex, where your toes twitch a bit. Have you guys seen that in your testing? That's really cool. Anyways, I'm not sadistic, I promise. And so then we collect pain ratings afterwards, and that's the design there. Okay. So yep, there's Michaela and there's John. So the y-axis is the change in pain ratings. And here you can see, this is time 1, this is saline, this is naloxone. You can see that similar to the rodent models, the female humans, I'm sorry, that sounds weird. They had greater analgesia during naloxone than saline. But in the males, we reversed it. Naloxone blocked the analgesia in the male model. So we deduced that there is sex differences in the regulation of pain in endogenous opioidergic processes, that males are using the endogenous opioidergic system and females are not. And we're trying to get this thing published, but I think I just got to stop sending it to male editors. And I think this is really important because we have, we treat pain the same between males and females, but if females aren't responding to endogenous opiates and they require higher dosages of opioids and more opioid prescriptions than males, maybe it's because it's not binding very well with females, and maybe we should be a little bit more sophisticated in how we treat pain in between sexes. It's just a thought. All right, and then what about change in, self-reported stress? You can see that, the meditations. Yeah, and there were no differences between the 2 meditation groups in this trial. You can see here that, stress goes up in time 1 from the beginning of the session to the end because we're administering heat and it's very stressful. And that, that there is a good effect-ish in the females when they're meditating during saline. But look at the males. I mean, they're really going down during meditation and stress, and that doesn't really work with naloxones on board. So that could be a pathway for how male-based analgesia is going away, is that its meditation stress relieving effects are also going away. We haven't been able to decipher that chicken or egg right there. So one reviewer could say, which they haven't yet because I can't get this thing reviewed, is, well, what if, because males weigh more than females and we're titrating naloxone dosage based on weight, that what if this effect is just driven by the fact that males are getting more naloxone than females? And so it is true in our study of 98, the males did weigh more than females. That's not really a big discovery, but that, and the naloxone dosage as a consequence of this was higher in males. but we ran a regression model and found that there was no relationship between dosage and the sex effects. So it's not dosage that's driving the effect. It could just very well be that the systems are just woefully different. And so this is the first study to show reversibility of analgesia by sex, self-regulated analgesia by sex. We've seen sex differences in opioid processing and pain, but never in pain relief. So that was cool in humans. And then here's another really cool finding. We talked about this at dinner last night, that our patients are producing dramatically greater relief by meditation in response to heat than our healthies. And I don't understand it. Maybe it's a ceiling, like a driver of a ceiling effect or a floor effect, like a floor effect here. They don't have that much further to go down, but the patients have a lot to go down because they're so high up, right? So that's just a cute little finding on the side. Okay, so in summary, we think this is the first time shown in humans. What could be driving this effect is that maybe in women, worst pain imaginable is different because of labor. This is where I stopped talking about that because I'm not qualified. But you know, if worst pain imaginable is that anchor, that could vary between males and females. And then, you know, maybe males are more stoic with pain, you know, and then especially if the experimenter is female, who knows, right? But I'm just trying to figure out other ways that this could be a driver. So,
We have one question.
yeah.
Was there any differences in pain rating between women with delivery history? Those about.
Question is, were there any differences in women that had delivery history versus those that did not? That we did not measure. We did not, I'm not a sex differences researcher. I plan to be. I weren't. And Michaela found this effect, and you know, now I'm all about it because it's so incredible. The results are so clean to me. So now that we're getting into this space, we're going to look at hormones. We're going to look at oxytocin, vasopressin, menstrual cycle is critical. Like you have to look at that. And then also history, you know, with labor. So all those things are really important. And so future iterations of this work will be much broader in scope. This is a fraction of the lab. And this is an old slide, ignore that. So this work was funded by NCCIH, the Hermera Foundation, and UC San Diego Sanford Institute for Empathy and Compassion. And I'm more than happy to answer any questions. Thank you. Yes.
Thank you for such a nice talk. My question is more about the expectation measurements. Did you measure any expectations? Did mindfulness meditation change expectations?
Great question. The question is, did we measure expectations? How much do you expect meditation to work? And the answer is yes. And we did not see that expectations predicted analgesia, nor did expectations did predict sham meditation relief, which gives greater credence that the sham is more placebo-esque. But no, whether you think it's going to work or not, it works. We see about a 99% response.
In relation to that, do you account for those who may have had experience with meditation in the past?
Great question. Question is, did I control for people that had meditation in the past? 100%. You are not allowed to be in the study if you meditated. So these were really naive, like in the literal sense. There are definitely, just like physical training, mental training has additive effects. And that would have potentially unblinded people to being randomized to the sham technique because they would have already experienced the genuine mindfulness. This was a much easier study to pull off in North Carolina than Southern California.
I think we have a comment online. In addition, the paradox is that women continuously experience higher pain than men because of different degree of pain during menstrual periods, which might give them more exposure to pain.
So I think the comment was that menstrual cycle can definitely modify someone's tolerance to pain. And I think higher menstrual cycle increases tolerance, I think is what you're saying. And yes, that is definitely true. We should have definitely looked at menstrual cycle and accounted for it. I would say that out of those 50 women or 48, 15 were not able to menstruate. And I could have said it more elegantly, sorry.
I'm interested in the stress-related relation. And you saw a difference between pain-free and just a slide before, pain-free and chronic pain participants. And chronic pain participants have a larger effect. Do you think stress can be related with that result?
Wonderful question. I didn't think of that before. The question is, do you think that this difference I saw in stress, did I look at the stress effect between pain-free and patients? And could that stress effect be a driver of this effect we see with pain relief? And I will do that on my way to DC today, and we'll look that up. That's a wonderful question, because maybe that ceiling effect I was talking about with patients is because they're also super stressed. And maybe meditation's first impact is on anxiety. Like, that's the first thing it does, is it, on average, the first time you ever meditate, it lowers anxiety by about 22%. And that's like a massive 300, N of 300. Okay, so maybe that this stress relief is translating into pain relief. And maybe that's the driver. So that's a wonderful, I will put you in the acknowledgements. Yes.
I want to make sure I'm understanding the naloxone and results you showed in men and women. So were you showing that women don't respond as well to the good for the rodent data, but then when the naloxone is administered before, they have a greater analgesic effect when naloxone is administered? Is that?
So the question is to clarify the sex differences effect in the translation from rodent to humans. What we see here in this slide is that it's analogous to the rodent data, that males are engaging endogenous opiates to reduce pain, that females are not. And here we show that because you see that, in fact, when naloxone, and again, this is really high dose, like we're pretty confident we're blocking opiates reliably, that when naloxone's on board, that they're reporting lower pain during meditation. And that could be because when the opiatergic system is being blocked, another system kicks into overdrive to compensate. But in the males, you still see like a drop, although this is not different. They're not different than baseline. The males are, which is like, it's no different than if they weren't meditating, statistically speaking. So this suggests that the primary analgesic system for males is the endogenous opiatergic system. And so this is the largest randomized crossover naloxone trial ever done, too. So that's why I'm kind of like, I think this is real. I think this is real, and obviously it needs to be done better, you know. But it's a first step in saying maybe we shouldn't be treating males and females the same for pain, which is kind of like a no-duh, but it hasn't necessarily been shown so clearly.
We have a couple more comments and questions.
The comments are the ones that scare me.
Thanks for your, thanks for your interesting presentation. And as you mentioned, first time the gender response studies, just recently the American Society of Addiction Medicine report in a Holy session, the difference between men and women in receptor affinity and drug response, also in redheaded women on the COMP gene looking at sound deficiency, which may bring some ideas, and explaining these important differences in a pharmacogenetic applying also to meditation.
That's the comment? Yeah, so thank you. That's a great comment. I'll try to regurgitate it. Basically, the Society of Looking at Addiction has also delineated sex differences in addiction responses, and that there may be some genetic precursors because impaired individuals have that unique genetic, and they are more or less,
Tolerant.
they're more tolerant of addiction. So we're going to Ireland.
And then the question online was any data collected on any continued effect of mindfulness?
The question is, was there any follow-up data to see how long the effects last? We have not done follow-up data in the 4-day interventions. They are one that I mentioned earlier. We do have a follow-up. So we haven't looked at it yet. Stay tuned. That is definitely something I need to work on to appreciate how long the effects are. I do believe there are dosage effects with meditation, just like there are with exercise. I do not see a difference between mental training and physical training. And the only reason we're seeing differences now is because we have brain scans. Like forever, Contento said, if I train my mind, I'm going to be more cognitively flexible and have the greater capacity to regulate my emotions. And we just typecast them as zealots, right? But it's different if someone says, I'm working out more, I'm working on my biceps, and over time you start to see bigger biceps, right? It's believable. Well, with mental training, now we can actually see from biological changes that, they co-vary with these self-reports. So that's why I think the brain is probably even more malleable than a bicep. Should be.
Great. Before you conclude,
We have one more question too. If meditation is more spirituality, how likely is the degree of a priori spirituality of participants or how they see themselves? How can that influence the training?
Question is, thank you. The question is, if meditation is spiritual, how do a priorities of spirituality drive the effect? We are very clear that there is no spiritual relation to mindfulness in our interventions. Again, I started this work in the middle of nowhere, North Carolina. Cannot do that. You cannot introduce Buddhism, spirituality, or anything like that. We have stripped it to the core and made it very clear that there is no spiritual or religious emphasis in the practice. Having said that, I would imagine in the community that if you are more open to spirituality, that you may be more open to practices that can modulate consciousness. But I have not verified that. Dr. Kologa.
there are some results show that there is no link between placebo effects and spirituality. So somehow it's in line again with your results.
Yeah.
But we do see a strong connection between spirituality and ability to upgrade expectations for pain relief. So
Very cool. Very cool. Any other questions? Yes, sir.
This isn't about your lecture per se, but I'm curious about your background in North Carolina versus San Diego. I haven't read your biography, so
I don't think I have one. The question is, what's the difference with my upbringing between North Carolina and San Diego? I went to college and my postdoc in North Carolina, UNC and Wake Forest, and now a professor at UC San Diego. So I moved there 6 years ago. You're welcome.
More questions online.
Okay.
Do you think that the central sensitization, more than peripheral sensitization, has better response to mindfulness and meditation, or both have?
Beautiful question. I love that question. Is there a difference in central versus peripheral sensitization as it relates to mindfulness meditation? It's a great question. I don't necessarily think they're separate. I think they talk to each other. But I think that meditation, I'd like to say that mindfulness impacts central more than peripheral, although we haven't seen data that differentiates between the two in the context of peripheral stimulation. We see dramatic effects above 30% reduction, and we see something similar in more stabilized metrics of pain, like McGill Pain Questionnaire and brief pain inventory.
And are you studying, or do you have any studies about preventative pain mechanisms of meditation and post-operative?
Great. And do I know of any studies, or have I done any that have looked at preventive metrics of mindfulness and or post-surgical? So Eric Garland published a really nice study, very large sample size, I forgot where it landed, where they used one session of meditation training after surgery, and they found lower pain and they got out of the hospital quicker than if they didn't, I think. And then preventive wise, that is an awesome question. Not that the other one isn't. Can practicing meditation inhibit pain exacerbation and or elicit resilience to developing chronic pain? Probably, but I don't know if that's been, measured. I don't know the answer to that, but that's a wonderful question. I wish that the NIH would fund me in that. Any other questions? Thank you so much.
Thank you very much to those who are online, and stay tuned. The next lecture will be May 13, same time, 3 p.m. Thank you.
Great.
Yeah.